Hey math kids, today we're going to talk about Venn diagram regions. We're in your book in section 2G and we're starting on example 7. And they start us off with a Venn diagram that looks like this. We have P and Q, and I did that kind of small, so I'm going to blow that up. And they have in parentheses a 3, a 7, an 11, and a 4, and they've marked our universal set as well. So it says use the Venn diagram to find the number of elements in P. So when we're looking at P, so in other words, we're asked to find n of P. I'm going to zoom back out. Okay. We have to add up the regions within P. So this 7, that represents 7 elements in P, and then this 3 is 3 in the intersection. But since P is considered the entire circle right here, we have to add those together. So it's 7 plus 3, and so the answer to that one is 10. Now the next one is the complement of Q. So we want to find n, Q, complement. And so basically we want to find everything that is not in Q. So Q represents this 3 and this 11 being added together, so we want to add the 7 and the 4 because they are not inside Q. 7 plus 4 is 11, and so that answers that question. Okay, the next one, they want us to find the number of elements in P union Q. So P union Q is going to be everything like that. So it's going to be the 7, the 3, and the 11. So that's 10 plus 11, which is 21. Okay, we'll get pink for this one. P but not Q. So P but not Q. Okay. So this one is what I call like the Pac-Man. So let me just draw a diagram. So like, I don't know if I like that one. Let's do, okay. So if this is P and this is Q, when it says P not Q, it's saying the part that's P but not the intersection with Q. So it kind of looks like a Pac-Man. Kind of, whatever. So the Pac-Man portion of P, which is just represented by the 7 right here. Okay. And then we want to do number of Q but not P. So it's the same thing, but it's the other Pac-Man portion. This time it's going to be this one. So that's represented just by the 11 right there. And then we have the last one they ask for is neither P nor Q. So that's like the complement of the union. So it doesn't want any of the stuff right here. It only wants the stuff on the outside, which is represented just by that 4. Okay. So we're going to move on to example 8. And this says, given n of u equals 30. So the universal, there's 30 elements in the universal set. And then in A, there's 14. And in B, there's 17. And then the intersection of A and B, there are 6 elements. Okay, it wants us to find n of A union B. So this is find and n of A but not B. Alright, so I definitely think we need to draw a Venn diagram. Okay, so that's our universal set. You know there's a total of 30 from this. That's not going to help us at the moment, but we will use that. Now, I would actually use this information in reverse. So I draw my A and my B. And the intersection has six elements. And then B has 17, but we've already represented 6 of those elements. And so there's 11 left over. And then the same thing with A. There's 14 total here, but we've used 6, so that means 8 of them are not represented. In other words, 8 plus 6 is 14, and 11 plus 6 is 17. And then total, there should be 30. So if we add all these together, we get 8 plus 12, so we're going to say 8 plus 6 plus 11. So we get 14, 15, 25. So 25 elements have been represented here, and so that means there's 5 more to bump us up to 30, and so there must be 5 elements that aren't in A or B. Now, once we get this Venn diagram, it's pretty simple to find how many elements are in A union B. So A union B is like whatever's in both of these circles. So we just need to add all those together. We actually already did that right here. And so that is 25. Now, the next thing it asks us to do is A but not B. So A but not B, once again, that's a Pac-Man thing. So it's just this area. And so that is represented just by the 8. Okay, hopefully that was helpful. If you need additional help, come to Math Lab and calculator.